Everything you are looking at here is part of one system. The electricity in your wall socket doesn't come from a single device. It goes through an entire chain, from medium voltage all the way to your distribution board. And most of these things are all around you. You just don't notice them. Today, we'll go through that entire chain step by step. This video follows the previous one, where we looked at battery systems and how they are actually used. Today, we move one step further into the real distribution infrastructure. We are not covering the entire electrical grid. We are focusing on the part that matters most here. The path from medium voltage to low voltage. From a 22 kV line through a substation all the way to your home distribution board. Not as separate components, but as one continuous system. This is where we start, medium voltage, typically around 22 kV. This is not the transmission grid that operates at levels like 400 kV or 220 kV and sometimes 110 kV. What we are looking at here is the distribution network, the part that actually delivers energy to consumers. These are the conductors. Higher voltage means lower current. And because losses grow with the square of current, higher voltage means significantly lower losses. These are insulators. They separate the conductor from the structure. That allows energy to be transported efficiently over distance. But this isn't just physics. Lower current also means you can use thinner conductors, and that directly reduces cost. It's similar to the difference between 120 volts and 230 volt systems. But there's a trade-off. If loads are spread out, it can be more efficient to use multiple smaller transformers instead of one large centralized system. Now we are inside a substation. This is medium voltage switchgear. This is one switchgear bay. It determines where the energy flows and allows parts of the network to be safely disconnected. These are switching devices. The system typically includes circuit breakers, load break switches, and earthing switches. Each of them has a different role. A load switch isolates equipment. A circuit breaker reacts to faults. The distribution network is often looped. That means power can come from multiple directions. And that significantly improves reliability. This is where the key step happens. The transformer reduces voltage from medium to low, typically from 22 kV down to 400 volts. These are high voltage bushings. The transformer works on electromagnetic induction, and it also provides electrical isolation. This transformer doesn't supply a single house. It can supply entire streets, or even a full residential block.
Protože na nízkém napětí jsou vysoké ztráty, tak vlastně dálková distribuční síť je na vysokém a velmi vysokém napětí a do místa určení, tam, kde se odebírá elektřina u malých spotřebitelů nebo větších, tak je potřeba to vysoké napětí transformovat na nízké napětí a k tomu právě slouží trafostanice.
This is the real function of a substation. After the transformer, we move to the low voltage side. This is the low voltage distribution board inside the substation. These are smaller circuit breakers. They typically protect auxiliary or control circuits. And this is the main circuit breaker. This device protects the entire low voltage output of the transformer, and it can disconnect the whole system if needed. These sections contain protection and distribution elements. They are used to control and distribute power to individual feeders. These are outgoing feeders. Each one supplies a different part of the low voltage network. Each feeder is independently protected. So if a fault occurs, only one branch is disconnected. This is where the transformer output is split into multiple directions. This is not control. This is real power distribution. From here, electricity continues to buildings and end users. Now we are at the level of a specific customer. This is the energy meter. And this is the main protection. This is the boundary between the grid and the user. This is where the system often transitions from TNC to INCS. That means the PN conductor is split into P and N. This is the final stage of the system. These are distribution boards. There is no single standard design. Each one looks slightly different. This is a circuit breaker. Basic protection. Multiple levels, more circuits. This is the structure before installation. Input at the top. Outputs at the bottom. This is where energy leaves the system. All distribution boards follow the same principles. Protection, safety, overvoltage protection, and power distribution. This is not about one specific board. It's about a concept. This is not an exhibition. This is the real world. Lines bring energy in. Substations supply entire neighborhoods. And pole transformers can supply entire villages. Small transformers supply individual loads. The form changes, but the principle does not. Medium voltage, transformer, low voltage, service connection, distribution board, and load. Electricity is not just a wall socket. It's a complete system. This is Emergency Power Lab. Thanks for watching and see you in the next video.